Hello everyone, I am Megshi Thakur. I will be presenting my research today called Designing an Explainable NLP Framework for Clinical Decision Support Systems using a design science research approach. This project aims to bridge a crucial gap between advanced AI tools and real-world clinical decision making. Moving on to the research motivation slide. To begin, let's talk about why this research matters. Clinical decision support system or CDSS are already widely used to improve diagnostics and treatment decisions. Many of these tools now rely on NLP, which is natural language processing, to extract insights from unstructured clinical data like progress notes or discharge summaries. However, most of these models are black boxes, which means they provide predictions but not explanations. In healthcare, that's a serious problem. Clinicians need to understand the rationale behind recommendations to ensure patient safety, in order to build trust, and also to make accountable decisions. This becomes even more critical in managing chronic diseases where clinical reasoning is often nuanced and longitudinal. Moving on to our third slide, which is research questions and objective. So this brings me to the central research questions. How can we design an explainable NLP based CDSS that not only predicts well, but also supports clinicians' trust and decision making through transparency? So my objective are fourfold. First, to design a modular framework that integrates NLP and explainability. Second, to ensure that this framework is aligned with how clinicians think and work. Third is to demonstrate its utility using real-world clinical scenarios. And finally, to propose a structural plan for evaluating its effectiveness from both technical and usability perspective. Moving on to our next slide, which is literature gap. The literature shows a strong body of work on clinical NLP, a growing interest in explainable AI, but there are key limitations. Most CDSS systems still prioritize model accuracy over transparency. Tools like Sharp and Lime are used in research, but rarely integrate meaningfully into clinical workflow. What's missing is a holistic design approach that accounts for clinical reasoning, user trust, and interface usability. There is also a lack of design science research in this space, meaning that while many tools are technically impressive, few are grounded in rigorous designs and evaluation methodologies. Talking about methodologies, to address these issues, I'm adopting a design science research methodology. DSR is well suited for research that seeks to create useful, innovative artifacts to solve real-world problems. This research follows 5 stages: identifying the problem, defining and developing the artifacts, planning a demonstration, and setting up an evaluation strategy. This structured approach ensures that the artifact is both theoretically sound and practically useful. And because DSR is iterative, it allows for continuous refinement based on stakeholders' feedback. Moving on to our proposed framework, this proposed framework consists of 3 main components. First is clinical NLP pipeline, which uses tools like CTakes and MetaMap to extract structured data from clinical notes using standard terminologies such as Node CT, UMLs. The second one is explainability module, which incorporates technique like sharp value, attention heat maps, and decision trees. These tools help translate raw models prediction into readable rationales. And the final one is clinician's interface, where everything comes together. It designed to be intuitive, responsive, and adaptable based off of the user's role. For example, a primary care physician might receive summary level explanation, while specialty could drill down into more detailed insight. Moving on to our demonstration plan, which is proposed. So although I haven't built the full system yet, I have outlined a detailed demonstration plan using synthetic EHR data such as from MIC third dataset. I will stimulate clinical scenarios involving chronic conditions like diabetes and hypertension. The prototype will likely to be built in Jupyter-based environment will showcase the full pipeline, data ingestion, prediction generation, and explanation visualization. The goal is to simulate real-world decision-making interactions, illustrate how explanations are adapted based on clinicians' expertise and information needs. And then our evaluation strategy. Evaluation is a key component of DSR. I plan to use both formulative and summative method. Formulative evaluation will involve cognitive walkthrough and think aloud sessions with clinicians, helping me refine both interface and the explanation logic. Summative evaluation will include standard metrics like precision and recall for NLP tasks, as well as usability surveys like system usability scale. I also plan to compare the explainable system with a black box model to evaluate trust and user satisfaction. Finally, any feedback from this process will feed into iterative design improvements, keeping the artifact dynamic and responsive to the real user's needs. Then our expected contribution. So what do I hope this research will contribute? First, I think a replicable and modular framework for building explainable NLP-based CDSS tool. Second, design principle and evaluation strategies that other researchers and developers can adapt on. Third, a proof of concept that shows how we can go beyond technical performances and build AI tools clinicians will actually use and trust. And more broadly, I hope this work contributes to the growing conversation about ethical and interpretable AI in healthcare, a field that is, I would say, desperately need more human-centered innovations. So thank you so much for your time and attention. I'm open to feedbacks, ideas, even potential collaborations. If you have any questions about any of the slides, the research design, methodology, I would love to discuss them in the comments. Thank you.